Good morning, Ray, and good morning, Devon. How are you?
Morning, Peter. Good, thanks.
Morning, Peter. All good. Plenty of moisture over here.
Yeah, we've got a bit of a wet morning in Western Australia. Our very northern tip isn't quite getting enough rain, but the rest of the state is pretty wet, really. So good start over here. Not so for the entire country, of course, but Ray, you've had, what have you had? 400 mils in your part of the world, haven't you?
Yeah, nearly had our annual rainfall.
And what did you say? You only got bogged twice, is that right?
Yeah, only got bogged twice. Yep. There's been plenty of fun out the wheat belt, but there's no money in dust.
Yeah, that's right. Yeah. Alrighty, let's get into it. So we're going to have a bit of a look at the integrated Harrington seed destructor. And I thought I might start here, Ray, and just a quick story of, on there's some logos of all the people that were involved. Can you just tell us a little bit about sort of how it came about, I guess, and what the involvement was with all of those logos on the screen there, all those organisations?
Yeah, Peter, I'll run through quickly. This project's 20 years old, and basically it was through a chance meeting with Steve Powell from ARI in the middle logo down the bottom that I was able to get an idea out of my head that we had built with Agmaster. It was sitting in the paddock. Basically, ARI came on board and vindicated my thoughts on how we could destroy the weed seeds, and that was the start of it, was dealing with the weed seeds, because I knew they were in the chaff fraction. I was only following up on data that was freely available around the state. So we tested the first mill, then we went over, we needed some money, so you go over to the GRDC logo, and GRDC, I don't know the number, but they've probably invested somewhere around 5 or 6 million of growers funds. So this is a growers project into this. So we then got the tow behinds going. When you go to the top of the screen, De Bruin manufactured the tow behinds, and there was probably a dozen of them around Australia. We had 2, but then we always wanted it in the header. I know it was 14 years ago that I had a car tyre stuck up in the back of my 2388, a 14-inch car tyre, and I said that's where I wanted to put the mills. And GRDC knew that that's where it needed to go. You go over to the right-hand side of the screen, UniSA were commissioned by GRDC to develop the integrated seed destructor, which then took another 5 or 6 years. We've been running the integrated one on the case for 3 years, and at this stage I will say to all the viewers, it's for all colours. This is not for one colour, it'll be for all colours over the next few years. And we managed to get the integrated. ARI did all the testing on the integrated mills as well through Michael Walsh, and then finally it was released on the 29th in a leap year of February, and you'll notice there in the top right hand corner, McIntosh and Sons have come on board with De Bruin as the national distributor. So we've got De Bruin on the left hand corner as the national and international manufacturer, and then we've got McIntosh's on the right hand corner as the national and international distributors. They will sort out the distributorship through not only their own companies but other companies throughout Australia. So they'll develop up a plan to best get the integrated across all Australian farmers.
Right, Ray. That's a picture of the old green one, and that wasn't the very first one, that was the second one. But how many years have you been towing destructors and then having integrated destructors on your farm?
So we towed the red one for 3, and then we've had one integrated. Forget about the colours. We've had one integrated for 3 and another integrated for 2. Now it's interesting that that's number 2. That green one's number 2, built in Kojana, and there was a huge amount of data. I think there was $80,000 worth of data collector on that enabled the university boys to get a whole heap of data out of that, and then go ahead and build the different style mills that you'll talk about in a minute to go into the integrated. But then there's a blue one which is number 3. That is still in the paddock. It actually sat in the shed for 2 years, my brother, and they're putting that back to work. So It's still exactly the same machine, but naturally integrated. So simple, it's in the header, you don't even know it's there, and it's just got its own monitors. It's no different to any other part of the header.
So is it 6 years all up, Ray?
6 years now, yes. And
this stuff, we often tell growers that 5 or 6 persistence to run down the seed bank in real life. Is that what you've found, and what difference has it made to your farm?
I think the big thing to say is for the first 3 years, you look at it, if you've got big weed populations, and bear in mind, I didn't start with big weed populations because I'd come out of a 66% livestock program. If you've got big weed numbers, you've got to drive them down. It's purely a numbers game. You only ever get 80 or 90% reduction with a herbicide or with a mechanical system. So it's once you get into 4, 5, 6, you see a huge crash in numbers. But bear in mind, you need to put on the top right-hand screen of your whiteboard in your office seed set controls. So every plant that you let set seed, we all know the old rule: 1 year's weed, 7 years pain. So you really got to focus on not letting anything set seed, and then after 3 years you see the numbers just drive down rapidly. Particularly radish. You know, I did it.
On your farm now, Ray, your numbers, when I've visited, I haven't been there this year, but last year they were very low. How are you finding your numbers on your farm these days?
Even lower again, Peter. Like this year, we've had the best data I can remember since the 1960s. But we were prepared to sow dry 75% of our program. So, and that's the big change for us. Particularly radish numbers. You know, I hand weeded known radish country. I put a trial crop in last year of 8 hectares, and I hand weeded it, and I only got 10 radish plants to the hectare. So we're seeing a huge crash in those numbers.
Yeah. So let's have a look at the original mills now. So we don't have data from the new iHSD mills, but this is data that Mike Walsh from RE at the time, he's now Sydney University, but Michael measured the efficacy of the original toe behind destructor with the cage mills, and you can see the numbers on your screen there in the high 90s of seed destruction for all of the seeds. I guess all we can say at the moment is the new mills are providing comparable results, but as they make small changes to the new mills, they sort of have to keep redoing this data. But so far it's all very encouraging that the new mills are destroying high percentages of the seeds, up in those high 90%, and that data will come out later on this year, I believe. But Ray, that is the old cage mill there, and can you tell us how that works compared to how the new mills on the integrated work?
Well, when you look at the two mills, you can see if you take the mill on the right, you can slip that inside the mill on the left. So now on the old machine, they were counter-rotating. So one going one way and one going the other way, and the material's fed in the middle, and it's got to get out. And you'll notice on the left-hand mill the air veins. Pete, you can scroll across to the air veins, see the flat bar on top there where you are, up. That creates the airflow. Now you've got to move airflow, and 80% of the horsepower in these mills is actually pumping the air. We can't interfere with the air on the header, and that was the biggest challenge of making these mills. And I have to tell the blokes on this program that this technology is 100 years old. It's a bloke named Stedman invented the cage mill, so it's 100 years old. But we had to alter it to pump air, because you can't interfere with the air in the header, because what you're looking at is the header has high volume, low pressure air to clean the grain. Now if you move the cursor to the hole in the middle, Pete, we've got to get high volume, low pressure air changed to low volume, which naturally increases its pressure. So we've got to get 1 1.5 square feet of air in that hole. Now, that was the big challenge. So in other words, you've got to pump enough air to create the suction to get the material through it. So that was the big challenge. So those two counter-rotate, one inside the other. Now the new one, and they're doing 1400 revs in opposite direction. Now the new mills, because they're counter-rotating, that's very hard to engineer. So the new mills designed by UniSA, Chris and Nick, is basically the outer cage now is called a stator, which is stationary. So that's actually bolted stationary. And then the inner cage sits on top of the hydromotor, which is very simple, one moving part, and that spins the same inside the outer cage, and that becomes the rotor. Now, there's a different pattern of bars and that on there that's all been part of the evolution of it all. It makes it very simple. Now, the big change is that one there is 1400 revs in opposite direction, and we all know about impact. The new one is 3000 revs with the inner cage spinning at 3000 revs. So because they weren't counter-rotating, you just double the speed of the inner one and you come up with the same impact. So these mills are purely an impact. It's like being hit on the head with a hammer. You could hit me with a hammer, Pete, tap, tap, tap on the head for half an hour, and you give me one decent whack with a hammer and that'll be the end of it. Now, that's what we're looking at. You've got to be a bit brutal. So we've built a machine that'll whack hard enough that it destroys all weed seeds. As much as we don't like weeds, they're a normal plant. The seed has an embryo and a kernel. We whack it hard enough, like all the growers know, if you harvest your legumes too hard, they won't germinate. Well, what we're doing is beating the weed seeds to death. So we don't have to turn them into powder. We've just got to crack the kernel, crack them open, and they won't germinate. So that's simply what...
People looking at this that might have seen the rotor mill back in the day will be looking at that thinking that's like the rotor mill, and it is a lot like the rotor mill, isn't it? But that harvest air were developing. But I think that's the key difference, isn't it? The rotor mill was grinding it into flour, whereas you guys have just come up with that impact approach, and that's probably been the key difference, which has been the key to success. Grinding that much volume into flour was sort of was too hard, wasn't it?
Yes. Look, we could have had this technology 20 years ago. They were exactly on the right path. There was no question about that. If they'd have built a big rotor mill the size of the cage mills we've got now, we would have been using their technology for 20 years.
Yeah. Righto. So that's a bit about the mill. And everyone out there, get your questions coming in. We haven't had any questions yet. If you've got any questions on your mind, type them in and we'll pause to answer them. So this is the new one, Ray. Just talk us through this. I'll move the cursor. You tell us what the bits are. This is the integrated.
So it's all fairly simple now. We've got two cage mills, which are a rotor and a stator. They're 750 mil across. We need two to get the capacity out of them, and they fit up behind the sieves. Now, if any of you with a lime green header, and I always talk colours, with a lime green header, you've got two chaff spinners in there now. They're exactly the same size as them, so you take the chaff spinners out and put them in there. With the case, you just take the tailboard out, drop these two mills in behind there. They feed into the centre. They've got two chutes that feed the chaff into the centre, and then it's actually spread out, and you can see the fine dust there, Pete, behind the wheel. Go up a little bit with the cursor. That's the fine dust coming out of the chutes in front of the straw spreader. So it's, I've had farmers come out and look at it and say, where is it? And I said, well, it's tucked up in there behind the sieves. Now, it will fit in all the colours. The dark green will have to lower them a couple hundred mil to keep away from their drawbar, and the policy is no oxy-torch on anything. The kits will just go straight in the combine as it is, the header as it is. It's as simple as that. This one's hydraulic drive. You can see the big cool on the fact. There's, I think there's 20 horsepower to cool the oil. So there's 280 litres a minute of oil to drive them. but it's all simple. You just watch the monitor, and we've run now, this one's run for us for the last 3 years. Basically haven't had a problem, except a lot of growers would have heard we had a problem startup. We had a hydraulic problem startup day one, haven't had a problem since.
So Peter, probably one of the things to point out is that on that, where you've got your cursor there, you see the cooling package. One of the charters for ourselves and the De Bruin engineering guys is to try and make the unit fit, so the unit you're looking at there, fit as factory fit as possible. So you won't, a lot of that cooling package where it's currently located there will be changed slightly in the new models for this year, and also refined for 2017 combines as well.
Yeah, thanks, Devon. Yeah. So, and I imagine the hydraulic pump and all of that sort of thing would be similar, and the size of the oil reservoir similar, or changes to that as well?
Pretty similar. However, you know, again, looking at the overall aesthetics of the combine and making sure that we want to get it to the point, particularly with this year's combine units or seed destructor units we're putting into combines, that you really look at the combine and you would barely know, as Ray said, he's had customers or farmers go to his property and have a look at this unit and say, well, you know, it's, you know, where is it? And you know, I had the same experience the first time I saw one too on Rose, on Michael's, I think, your nephews.
Yeah.
And certainly, so it is pretty good. We're just about, you know, a lot of the work that De Bruin Group and ourselves are doing are really tinkering with that 5%ers, you know, the 2%ers, that just making it that little bit more factory fit.
Yeah, excellent. Now, one question that does come up, and I don't know if it's probably a good time to cover it now, is what about header warranty and that sort of thing? Is there any issue there with, you know, fitting something like this aftermarket to a harvester and its warranty?
So look, at this stage, a lot of the inquiry for this year's combines will go on to used machines. Certainly Case, New Holland or CNH Group are very much in favour and supportive of the product, and so we've had no issues there. We've had a lot of support both in Australia and overseas with regards to the fitment of the iHSD on the combines within the CNH Group. We know that there may be some issues with some other colours at which probably prefer not to get into right now, but there are some issues that have been worked through with other combine dealers and their manufacturers, and but you know, it's probably fairly new for a lot of those. We won't, whilst we have every intention of fitting these units to every colour combine, the reality is just for this year and possibly next that we're going to, it's really an engineering feat that we've got to overcome to make sure that we can get them available for every combine. So we have no intentions of limiting the unit to just Case or just New Holland or whatever colour. We have every intention of being able to supply to all combine colours, and I guess at the end of the day the market will determine you know, what colour combines and what level of support they get out of the major manufacturers.
Okay, thanks, Devon. Now I've got some questions coming in from the listeners out there, which is great. So first one is, how does capacity go in canola where there is more bulk with potentially oily chaff? And just before perhaps you answer that, Ray, in my measurements, when we're using a chaff cart, if we compare wheat with canola, in canola we get about 1.5 times as much chaff per tonne of harvest than we do with wheat. So yeah, it is a high chaff sort of crop. How does it go in oily canola chaff, Ray?
No change. The limiting factor in all the crops we've harvested over the 3 years, the limiting factor of the machine has been its own header losses. So that's the only thing that's limited us, bar we had a problem in the early days in lupins, and we eventually found we were overloading the mills and lupins, and we eventually found the header we'd bought, the concave hadn't been fitted properly, and there was about a 70 mil gap in the middle at the bottom, and it'd been like it since new. We fixed that up, and we have not had a problem where the mills have been limiting up to class 8 and class 9.
Yeah, and if I could make a couple of other comments. So I've spoken to growers that have adopted chaff carts, and they said the first time they put them into a canola crop, they saw these big black heaps, and then they realised how much canola they'd been throwing out the back of their header for a lot of years. So I think there was another farmer up this way did a pretty detailed study on it, where if you were harvesting anywhere near engine capacity, you're throwing a lot of grain out the back, particularly canola, and the only way he could fix it was by slowing down. So I think I would reiterate your comments there that what we're limited by is header capacity for grain losses, not so much the mills. Is that fair enough?
Yeah, I'd comment on that. I think one of the biggest changes we've seen to headers in the last 20 years is it's gone from the biggest header you could buy was 280 horsepower. Now we're scratching up around the 600 horsepower. And if you looked at some work that came out by the Condinen Group last year, their header losses were huge, up to half a tonne to the hectare by just running on engine horsepower. And I think this is a big new learning curve we have to go through with all the colours. Is basically you want to get paid for what you get in the box. So if you're losing grain out the back of the header, you're losing weed seeds, and therefore you start to lose the game.
Probably, Peter, just one more thing I can add to that is that one of the major focuses of the De Bruin Group and also ourselves in the testing that we'll do on the 9090 combine that we'll have into that Mount Barker area in the next few weeks, but also the units that are going into the 2016 harvest, this coming harvest, is to make sure that we are in an area that we supply a lot of the bigger combines because of our moisture conditions. And so one of the major focuses for us will be to make sure that the cage mills are not the limiting factor to the production or the capacity, I should say, of the combine. So that is where a lot of the monitoring and a lot of the testing that will go on as of basically next week will be about making sure that those cage mills are not the limiting factor.
Okay, right, we've got loads of questions here, so we'll try and answer them all quite quickly. The next one is, how many hours is the cage mill expected to last, or the cage expected to last, and is there a price list available on wearing parts?
Well, I can answer the first bit. Our mills have done 700 hours before we change them out. Now, we're seeing a wear pattern in the bottom of the slats now. There's a lot of research work going on, and members of the audience have to realise this is going to evolve. We've got huge research team working on little things like this. So what we're finding is the bottom 30 or 40 mil of the 100 mil cage mill is wearing out first. Now they've got a team here at UniWA looking at material flow. If we can spread the material out over the bars, we want to get them to 1,000 hours, so that we see most combines in Australia doing 500 hours a year. And if we can get 2 years out of a set of mills, Bevan will tell us roughly what the mills are going to cost. I know they're not very dear, so we'll have to change. We're trying to get them 2 years, so you change them out. And Michael Walsh did some research on some worn mills of mine, and they only lost a couple of % efficacy over that period. So that's where we're aiming for. But I'm sure with the team we got going, we're going to get it even going further than 1,000 hours.
It's certainly one of the better. Sorry.
Just is there a price list yet, Devon, of the parts, or not yet?
So there's a little bit of work going on with that right now, because the units that are coming out this year, there's been some changes in the composite of the material used in those cage mills. So what we're looking at the moment is they'll be roughly around that $2,000 to $2,500 to replace those mills. But as Ray pointed out, we can. One of the things with increasing or changing the composite of that material in those mills is that you can actually go beyond. That can add so much more additional cost in terms of the replacement cost of those mills that it's actually not worth it for the extra 20% you might gain from the wear factor. So there is a happy medium that we're trying to reach, where we can get the composite to A grade that gives us up to that 1,000 hours, and that's what everyone's working towards, and that's what De Bruin Group will be testing, particularly on those units this year. But we're pretty happy, and everyone seems to be pretty happy that I've spoken to from around Australia with those sort of numbers that Ray's talking about. and that durability. But we're certainly we've probably got another step that we can go as well.
Okay. Next question, is there any issue with fire danger?
None whatsoever. There's no close moving parts. The first thing, one of the things you do have to realise is there's a lot more dust. So for those people that won't clean their headers down, there's an increase in risk. You look at your slide there. There's a lot more dust. But as far as the mills themselves go, there's no increased fire risk whatsoever because it's not a close grind or anything. Yeah, not a problem.
Okay. Now this one we might later, but how will they fit into a New Holland, and is mechanical drive an option? Do you want to cover that now?
We can cover it now if you like. Yeah. So no, there won't be mechanical drive. There's nothing on the there's nothing that ourselves and De Bruin Group are doing right at the moment in terms of mechanical drive. The best system that we've currently got available to us is to stick with the hydraulic driven option. There are, and certainly Ray's a fan in terms of looking at options in that regard down the track, and maybe, you know, who knows, there'll be an evolution of this product over time, and whether that's, you know, 5 years or 7 years, I can't answer that, and probably something that we're a couple of years away from establishing. So in that regard, that's where it's at with the hydraulic option.
Yeah.
So what was the other part of the question, Peter?
Yeah, New Holland.
Yes, so they'll be going into, well, this year in particular in WA, we're fitting quite a few New Holland combines. The first one that we'll go into is a 2011 elevation model 9090. So, you know, common practice for us to sell 9090s, 10.9s, 9.9s, 8.9s, and so we've got a mixture of all those combines with seed destructors this current harvest that's approaching.
Yeah, excellent. Now here's a good one. I can understand the flow of the counter-rotating mill, but what effect is the stator on moist chaff with flow and blockage?
The interesting change with the two styles of mill, one's a round bar and the rotor stator is a flat bar, which generates the air. Now you're never going to be harvesting grain that's any wetter than these mills will handle. It's as simple as that. You'll only harvest grain up to 14% moisture. So these mills, the design of the new rotor and stator with the flat bars, that's what generates the airflow. So you're never going to be harvesting grain that wet that it's going to block it up.
Okay. Now there's a couple of questions about this. How do you judge grain losses if everything is milled?
This is a very good area. This is an area we've been working on, and I was talking to Bevan earlier. They've come up with a kit that's going to go in, and I think if we go back to square one, it's about calibrating the monitor. The moment you do your losses test, you equate it to the monitor, and you adjust the monitor and say that's I'm going to work off. So before I was talking to Bevan this morning, I'd already made up my mind I was going to do our own headers next year, which was take the two chutes off, put a slide in, open the back of the case up. You can see there on the screen, you just pull two triggers and the hot straw spreaders go up. And then I would just do a windrow and put my collection tray under there, and I do the numbers in the collection tray, and I know what my grain losses are when I put the canola in a medicine measure by the mill. Bevan, they've come up with the same thing. They're going to put a panel in where they can actually divert over the mills, catch the material, which you'll turn around then and calibrate your monitor, because you only drive on the monitor anyway.
Yep, excellent. So there, you guys are working on something, and yeah, and dare I say, you might even be able to improve how well you measure grain losses with that, Ray, if you do end up with that narrow sort of windrow of chaff rather than spreading it everywhere.
I think the narrow window, because I know if I've got a couple of windrows up the paddock 100 metres, I'll just burn them later anyway. And I think it's going to be the best way, because the spreaders on all the machines don't spread the losses even enough to get an accurate thing. And I'd made up my mind I was going back to the 1.5 metre width of the back of the header, and that's where I was going to test my losses across that 1.5, and then I can do the mathematics on it.
Yeah. I might just cover 2 more quick ones now, then we'll keep on going. If the mills wear uneven, will they go out of balance?
All I can say is you're asking the question if they wear uneven. On the time I've spent with them, they're doing 3,000 revs, they can't wear uneven. They're just going too fast and the material's being fed in. As they're worn out, I've only worn one set out and they didn't start to vibrate, so that I can only apply that experience to it.
They sort of wear evenly uneven, don't they, Ray? They're uneven in that one end of the bar is worn more than the other, but all of those ends are worn equally.
That's right, and that's where we're looking at the chaff entry. It's the inertia of the chaff that's going to the bottom that is wearing the bottom of the bars, and we've got people here at UWA looking at models. I had a meeting last week or the week before. They're looking at models of spreading the chaff out over the bars to get more even wear, which will give us more durability. So if we're wearing 30 mil out of 100 mil and we can spread the material over the 100 mil, we will get, I'm sure it'll be exponential, we will get more than 3 times the life out of them.
Yeah, righto. Excellent. Now, last question for now, which I think is a good one. How wide will it spread product?
It won't go right out. It won't go right out as far as straw. But if you notice there, you'll notice there that there's always a bit of breeze drift because the material's so fine. The breeze, the air takes it most of the way. Yeah. And you've got to realise how little there is in a chaff stream. We look at the chaff carts and you look at the amount of chaff going up the belts. It's so little. I reckon if you just join your index finger and your thumb up and make a round circle, a stream of chaff's only as big as what will go down through your thumb and forefinger. So the wind and that does just let it drift across the paddock.
Yeah, thanks, Ray. And from my measurements on chaff carts, I think we're looking at about 10 to 15% of the residue in the chaff and the rest in the straw. So, okay, we'll leave the questions for now. We'll push on. We've been going for 35 minutes. We'll try and wind this up in the next 10 or 15, but we'll see how we go. We've got lots of great questions coming in. So we'll finish up our slides and then we'll get to all of those questions at the end, I think. So, Ray, we'll do this quite quickly, I think, a little bit on the header setup. So we've got this concept here of using a separator baffle. This is a drawing done by engineer Nick Berry showing, you know, the grain coming into the thresher, out of the separator onto the sieves, and then out the back it goes. And we're talking about this separator baffle here to try and divert chaff below it and straw above. And the next picture here sort of shows the separator baffle in the back of your harvester with the iHSDs fitted. And I think this is about 30 centimetres from memory, Ray. And the one on this side is removed, so you've only just got one baffle there that you're showing us. And yeah, do you want to just talk a little bit about that separation, Ray?
This is key for both the iHSD and chaff carts. We've worked out through the union that you need about 300 mil above the sieves, because then you let the rest of the air go straight through the straw on the colours that have a multiple system. The lime greens have, it's not important, but you only need to trap that 300 mil of air that's containing the wheat seeds. And you'll notice where my fingers are, that splits the air and lets one lot of air go over top and one lot direct it down, so the hole in the mill's down under the word chopper. So very important for both chaff carts and the destructor setups to have that baffle positioned like that to separate it.
Yeah, and the mills suck air, don't they?
They do, and that's the beauty of it. The part of the design, the mills have to use more air than the headers generate. So then you don't have to worry about sealing them all. So they naturally draw air from the outside, which keeps it clean, stops the chaff or billowing up around the motor and all that. So most of the horsepower, 80% of the horsepower, is actually to drive the mills and pump the air. So you know you've got 1.5 metre by 300 of air there that you've got to get into 2 holes that are only 400 across or something.
Yep. Okay. Righto. So just I've just found out my question box here is blocking things a little bit for you all. I'll put that out of the way. Sorry about that. And just a little bit more on the harvester setup. Ray, you are in the back of your harvester, but I spent a bit of time in the inside of the harvester with you, and we've done an RE inside on this, but just a little bit quickly about how you set your harvesters up to maximise that efficacy of harvest weed seed control.
I guess the best way to describe it is I open my machine up as much as I can. I go to where it's too much, then close it up a bit. Like I've always got wires out of the grates, out of the concaves, and it's really getting as much grain down onto the pans as I can, because that's where the weed seeds, just treat the weed seeds as grain. I either want it in the box or down on the sieve so it can go through the destructor. So that's the real important bit for mine, and I have been a bit critical of some of the machines that come in. I believe they're too closed up. Don't be afraid to open them up as much as you can.
So we've got the next slide. This is the first section of your concave, isn't it? And then the next slide, grates here.
So these are the grates.
Not quite, but not
I
far.
like these grates. You just about get golf balls out through them. and some of the colours, they're way too tight in my view. That's why I'm pleased with these. My old 2388, they all got opened up with the oxy-torch. Cut the panels out, and but you go and buy a modern one, they're opened up anyway. So that's just one thing, is whatever you're using, try and open up those concaves and grates as much as you can.
Get the weed seeds out.
They're the same panels off the old 2388. Well, every second slat was cut out with the oxy.
These ones in the top here, you cut these bits out, eh?
No, I don't have to on the modern one, because the bottom halves are open.
Right,
they were actually the bottom half on the earlier models. But it's about opening it up. Simple as that. You know, blokes know themselves what to do. Just don't be afraid to open it up, my view.
Righto, so just we're talking about the iHSD's got full residue retention. This is just a picture of a crop that's been harvested with one, and showing that full residue retention on the ground. And we do have a video here which I'll have a go at and see if I can get it to work. Just give me a moment. It might be a little bit jerky for you, but this is just a video of Ray's machine in action. Lisa took this video last year. Some of you, your bandwidth might struggle a bit with this, but I guess the main thing to note is big clouds of dust coming out of the thing, Ray.
Yeah, well, you're actually, I'm seeing all the time, you're actually getting more spread with it, and there's so little of it, so fine, you're not going to get that stratification of it. But the main thing is you just drive this machine as if it's not even there. I had cameras in my early one, and young Matt was driving it, and I got in the header one day and the screen had broken its mount, and he disconnected it, and I had a camera in each mill, and I said to Matt, we've got to fix that screen up, and he just said to me, Gov, don't worry about it, they're never going to block up, we're not putting the camera back on. And the new one hadn't got a camera on it. So you just drive the thing.
Yeah. Righto. So let's see how we go here. That's a bit of a picture of the destroyed chaff. I think that's a blue seed.
Look at it. Notice the chaff's not all ground into powder, and bits of those chaff are as long as a ryegrass seed. Now the reason those bits of chaff didn't break in half or anything is because they haven't got a hard centre. They haven't got a kernel in them. So once some of the bit right down the bottom next to my index fingers, as big as a ryegrass seed, come down with your cursor. Come down, straight down. No, down, oh sorry, down my little finger, not my index, I've got it wrong. Come right down the bottom. Now that's one. Now the head up to the right. Head up to the right. There you go. That's as big as a ryegrass seed. Now, that hasn't broken in half because it hasn't got a hard centre. And now, it's the hard centre that gets impacted, and that gets broken, whereas that bit of chaff, because it's not a hard centre, it just went through. And it's really about the kernel and that in the seeds that get shattered.
Yeah, and I think this is actually a picture of Michael Walsh's research, and he dyes the seeds blue and then has students in a lab sorting through it for months and months on end to find these little blue seeds, and then they measure the germination of them. That's how all this testing is done to test the efficacy. They put a known number of seeds that are dyed in the front. And let's talk a bit about the big $1 million question. It's not $1 million, it's a $160,000 question of cost. So I've got here a very rough estimate of what it's going to cost to run these mills. Now, Devon, firstly, the capital cost is $160,000 plus GST. Did you want to comment on that at all?
Look, we're basically, it's the next year's, as pretty obvious, for 2017 harvest, the orders are coming in now, and that's the set figure for next year. That includes the fitting of the units and also the infield startup. So that's one thing that we're very mindful of, and we're obviously aware of your work, Peter, with the cost per hectare of windrows and chaff cart options, and we're certainly very keen to keep a minimal cost on it. And we think that it's and been very well received, and obviously the units for this year are sold out, and the units for next year are well underway.
Thank you very much. Now, if we look at the running cost per hectare, now I just have to warn you, as I've written here, this is a rubbery figure. It's hard to know exactly, but I'll talk you through that. I've estimated that figure there of $17 a hectare, and the way I did that was the most of that is the capital cost, and there's a million different ways to measure, your finance costs. But what I have done is finance it over 8 years at 6% interest. So that gave us a capital cost. If we are harvesting 2,000 hectares, it gave us a capital cost of $13 per hectare. So obviously, if you're harvesting more hectares, then that capital cost comes down, or vice versa. The rougher bits are estimating fuel and maintenance. Now, very hard to do. Ray is better positioned than anyone. All I've done is assumed about 2 litres of fuel per hectare extra, and it could be more than that, potentially. And I've allowed $2 a hectare for maintenance, and that is a straight-out guess. But I needed to do this to give us a ballpark figure. And the important thing is that when we're looking at harvest weed seed control tools, all of the other tools, we have to measure this nutrient removal cost, because we are removing nutrients from the paddock with all of the others. The biggest nutrients are nitrogen and potassium. Potassium's probably the biggest of those two. And if we use the nutrient costs and we compare this with windrow burning or chaff cart for a 2-tonne crop, they are all very comparable. They're all quite similar, around about this figure. If you go to higher yielding crops, the chaff cart and the windrow burning becomes more expensive because you are removing more nutrients. But it is important to compare apples with apples. We need to consider these nutrient costs, and this is why I've had a spin at coming up with a per hectare running cost of the destructor. Now, Devon and Ray, would you like to comment on my assumptions I've made there and tell me how close we think we might be with this number?
Pete, I would have said 2 litres of fuel. I can't measure that because I'm not going to run without it for a start. But I reckon that's a good number. You're pretty hard on the bank interest at 6%. But look, yeah, all I can comment is on fuel. All I know is if I'm using 2 litres of fuel, well, that's the same as running a boom spray over. And what about when we get to the stage where we can't use a boom spray? So if it's costing me $17 a hectare to run the thing, at least I'll be able to stay in the game and That's really what it's all about.
Peter, from our perspective, we'll be doing a lot of work on fuel usage and trying to measure that and feeding that back to yourselves. And I know the Brewing Group are very interested in that data as well. There'll be a lot of work going on that, and I think that'll be an ongoing issue that we'll be measuring in the years to come. With regards to finance, out of the 87 customers that are registered on the iHSD website and that I've spoken to around Australia, most are looking at either an outright purchase or otherwise a finance package over 3 or 4 years. So whether that makes any difference, and I think we'd expect a slightly better interest rate.
I'm glad you're not my banker.
Yeah.
So that's where that's.
I've obviously done an interest rate looking into the future and used an old average, not the exact current interest rate. So, and look, no matter how, I'm not an economist. I consulted the Plant Farm consultants on that one, and they said, look, no matter how you measure it, someone's going to tell you you've done it wrong. But here is a ballpark way of doing it. And I've done it over 8 years. You know, should it be financed over 3 or 4, or how long you're holding the harvester for? You know, there's all of those things as well. But anyway, okay, so just to keep going, and just a few more slides to go, over to you, Devon, about the future or just the plans for rolling them out in the next couple of years.
So a lot of the questions that I've had, again, from the registrations through the iHSD website have come about, you know, what sort of numbers are involved, or what sort of capacity can we expect, and when do I need to put my name down for one. So in relation to that, I quickly put up some numbers here with regards to 2016. They're pretty much where the mix of the units will go next year. Obviously there is a focus in WA, particularly with our ability to monitor and install the units, but also monitor and spend a lot of time on those units this year. For 2017, as I said, there's quite a few already sold. Some sold subject to the availability of the units and the kit that comes with the unit to fit on other colour combines. So, you know, we'll be working with the Brewing Group and working pretty hard over this coming harvest to try and establish those kits. But we think somewhere around that, you know, 2017, 30 to 40 units, 35, 40 units, you know, is pretty achievable out of the Brewing manufacturing plant. We may get to a point, given the level of interest that we've had for 2017, that we'll try and push those boys a little bit harder and try and get a few more units out of them. But at the moment, the agreement is that somewhere around that 35 to 40. Following that, 2018, again, the expectation would be that we'd be up around and in excess of 100 units out of the Mount Gambier factory through the Brewing Group. So they're pretty much what the plan is for the next you know, few years at least. And but anyone really, the point here is that anyone that wants to you know, get involved and get a unit for 2017 really needs to, one, register, and also you know, secure one in terms of signing an offer to purchase for one to be supplied for 2017 harvest.
Excellent. Thanks, Devon. And yeah, we've sort of covered this a bit, I think, but the plans are, I'll let you cover that again just quickly.
Well, I mean, I think the point is that, you know, yes, we've got some issues, well, not issues, but we've got some manufacturing and planning, you know, items to overcome in terms of fitting them to every combine colour. But I think the important thing here is that I hear quite a lot of feedback from, you know, other dealers and also a lot of customers from other brands that, you know, is the McIntosh Group solely supporting this product on the yellow combines? And the answer is absolutely not. Our intention is to have this product, which is a fantastic initiative, awesome you know, development for the industry, and to have that available for all combines. Our main thing is that we want to be involved in the fitting of it, so that we are absolutely in control and making sure that the product is fitted correctly to all the combine colours, and you know, making sure that they're at maximum performance once they're out in the paddock. So that's our interest. It is not about keeping it solely for yellow or red units.
Yeah, and sorry, the question here is actually also around fitting it to new combines.
Yep, sure. So new or used, retrofit or brand new combines, not a problem. The same principle applies. We want to be fitting those. We won't be sending kits out to individual, farmers to fit themselves, and we won't be sending kits out to any dealer around Australia. We will be looking at, particularly around harvest time, we'll make some more announcements with regards to distribution around Australia and what dealers are involved in the project. We don't need 500 dealers around Australia for this product. We need the biggest, or at least the most experienced combine dealers in the regions to be able to make sure they can supply and support this product. And that's what it's all about, and that's what we're interested in doing, and that's how we'll set up the distribution around Australia.
Yeah, excellent. Now, the next slide, we have covered that. And just quickly, we're finishing off on these last couple of slides, the pros and cons, which we have talked about a bit, but it is that full residue retention, no burning, so destroying weed seeds while retaining. But this next one, Ray, nothing to do after harvest. That's got to be a big one, doesn't it? You finish harvesting the crop with the integrated destructor fitted, and the job's done.
Yeah, no, look, it's so important. You know, we've done row burning and that sort of stuff, and it takes time. And if you realise the whole of Australia has to be doing something with harvest weed seed management, we can't afford to light the whole of the country up, and then we get a weather event come through. And way back when I first started, I could have used a chaff cart, but the key to what I wanted to do was not use a fire because of the risk. You know, I remember Cyclone Alby well, where we had the whole Shire alight. And that's important. You finish harvest, you go on holidays, the job's done.
And also,
I think, Peter, sorry, Peter, the other point I think about the cost per hectare and in the relationship between, this product and the windrow burning and the chaff cut options is that the cost is not just about the running cost. It is about the ability for people to manage it in one pass and to do that once and not have to go back. I mean, the time and the resources that people spend on windrow burning and managing chaff piles, after the fact is enormous. And that's the thing that shines through when I'm talking to people around Australia about this product. That's what they're trying to get away from. So, I think there's a lot of benefit in that as in relating back to the cost per hectare.
Yeah, I think you're right. That's not necessarily $1 per hectare cost. That's an emotional cost, isn't it, of having to do that job and be out there all night burning windrows and that sort of thing. We've talked about the level of seed destruction being high, but also this ability to treat every crop hectare. A focus paddock study I've run, which I talk about a lot, but we had harvest weed seed control every second year, and that was very, very effective. With this machine, we'll be able to do it every year, every crop, and that will have a massive impact. And the cons, well, we've talked about these too. We've talked about capital costs. That is a negative, obviously, that the growers have to fork out for it. The horsepower requirement, we haven't talked about this, but we are in that 80 to 100. Any comments from you guys about that?
Yeah, I think 80 is the top. But what I can see, I've got a Class 8 and a Class 9, but what I can see, I really think 80 is tops. I reckon it's more 60 to 80 by the way these machines are working. So, which surprised me. I was expecting 100. Happy to go to 100, but I reckon it's actually a lot less than we thought it was going to be. But these Macintosh group, and they'll find out all these numbers a lot better than I've been able to find it out. But my 8 will run in the same paddock as the 9. The 8 runs at 100, 102%, and the 9 runs about 94, 95. So, and there's 35 horsepower difference in the both of them. So I'm guessing it's only up around that 60 to 80.
So Peter, the Macintosh group and also De Bruin group have been probably pretty conservative on our numbers there. We're certainly not keen to put ourselves in a position where we're out marketing that it's 80 until we've done the research ourselves with the units that we're fitting this year, which everything is about improving the efficiency of those pumps, about the hydraulic lines that we're fitting to the mills, and there's already quite a little, well, not little changes, quite significant changes in the way that's designed for this year's models and next year's so far that we can see some significant horsepower savings. So we'll be able to report more, and anyone who's registered on the iHSD website we'll get in further updates and information as that becomes available.
Yeah, and from my perspective, a lot of growers will probably disagree with me, but I don't think it's a big deal because, as Ray mentioned earlier, in harvesters these days, the horsepower of the harvester outweighs the sieve capacity, and growers that are harvesting at 100% horsepower of their harvester are throwing a lot of grain out of the back, and the studies I've seen are very convincing of that. Condon Group and some growers up this way that have measured it extensively. So I think that the harvester will be able to operate at full capacity if you don't want to waste grain. We've got the increased fuel cost. Like we said, we don't know exactly what that is, but we will measure it. This is another one we haven't spoken about, and we haven't measured either. But it's likely that given that it destroys grain, you're going to destroy a lot of your volunteers, which would make stock feed. Ray, I don't know if you've seen anything there visually. Is this right, or do you think it's a bad idea for livestock producers to have an iHSD?
It could well be. There's some work coming out now where the amount of livestock they feed they're getting out of chaff heaps. So if that is actually the case, that's fine. Use a chaff cart because you've got to do what's best for the whole gross margin of your farm. But we've got a huge amount of Australia that doesn't run any livestock. And there is no one fits all in farming, we know that. And if I was running a big sheep flock and this destroyed sheep tucker, I would be using a chaff cart. But there's still a big swag of Australia that doesn't have the luxury of sheep to clean up after them. So there's still a very big market. And that'll evolve over time. There's work being done on that.
Yeah, and I think it's a good point. There's been people that have said that this is the end of the chaff cart. It certainly isn't. The chaff cart's got a huge fit for livestock producers. Okay, a couple of questions to finish off with. Can the unit be disabled to allow straw baling? Well, from my point of view on my red header, I leave the iHSD going, and I just open the back, which I did in a crop. I just open the back and bale the straw, and that means that the weed seeds and that don't go into the bale and fall out the bottom of the bale anyway. So I just want to bale the straw. So I wouldn't risk losing weed seeds by not putting them through the mills. For the amount I would get in the bale, I would just happily just bale the straw. What about if something goes wrong and it's broken down but you need to keep harvesting? How difficult is it to disable it and keep going? The short answer to that is I wouldn't. I'll fix it the same as if I had a flat tyre. It is part of the process. You've got to understand if you let these weed seeds go and they're resistant, they will just grow again and have 500 seeds. So if you've got a flat tyre, you don't keep going. If the mills are blowing up, you just fix them. And that's how adamant I are with my operation. There's no such thing as not using it all the time. I love that answer, Ray. I could stand in front of a bunch of growers and say that and they wouldn't buy it, but they'll buy it from you, I think. Okay. Well, that's the way it is. Yeah. The final question I've gotten, if there's any more questions out there, put them up now. But the final question is what litres per minute of oil flow is needed? It says LPM. I'm assuming that's litres per minute, is it? As far as I know, it's 280. So 200 litre drums a minute. It's a colossal amount of oil. But look, it's all engineered to do it. And I'm going to make the comment that all the components so far that we've used are all off the shelf. So that's very important. The pump's off the shelf. It's a Rexroth pump. The motors are off the shelf. Everything's off the shelf, and that's so important for the industry where you can get parts. And the two policies were you're not allowed to use the oxy torch to fit it, and everything has to be off the shelf and available.
And I think, Peter, probably further to that, it's really important, I think, and a great attribute or feature of the product that the cooling package is removed from the combine itself. As much as the oil flow, it's one thing we know in some of our conditions, particularly in WA up north, and I'm sure in parts of New South Wales where it gets extremely hot conditions, we don't want to be relying and drawing on the cooling package of the combine. So it is completely separate. and there is no contamination between these units and the combine, and that is a massive, well, it's an obligation that we believe is critical to the product and also in maintaining the integrity of the combine.
I think it's a great point, because if you have a malfunction on hydraulics, we all know what happens. And so if it's got its own circuit, you just sort out its own circuit. And likewise, if you have a blow in the hydraulics header circuit, you don't want to contaminate the other circuit. So it's a great policy to have them split.
Righto, I think we might just about wind it up there. I'm going to finish with an advert. It's for Diversity Era. Diversity Era is our online learning platform, which is on the WeedSmart website. We've got one course up which is on Herbicide Resistance 101 to help people understand herbicide resistance, but the next course, which will be up in a couple of months' time, is about harvest weed seed control. And we've done a module on each of the different harvest weed seed control tools. It's designed with growers and agronomists in mind, but probably primarily growers. And quite a simple online course. If you're thinking about weighing up which one of these tools you're going to get into, this will be a good course for you. But I'll finish up by saying thank you, everyone. We've had a good group on for the entire webinar, and we've gone for a full hour, so thank you for staying on. And we always think we're going to finish these things under an hour, and we always get talking, and we've had some fantastic questions which have kept us going. So thanks, everyone, for participating, and especially thank you very much to Ray and Devon for giving up your time and coming and participating in the webinar. We really appreciate it, and I think it's been a fantastic webinar.
No worries. Thanks, Peter. Thanks for being together.
Thanks, everyone, and we'll see you next time.